The next problem we're going to look at from the Grind 75 list of questions is merge two sorted lists. You're given the heads of two sorted linked lists, list 1 and list 2. Merge the two lists into one sorted list. This list should only be made by splicing together the nodes of the first two lists. Return the head of the merged linked list. So in the example they give you first linked list is 1 to 2 to 4. And the second linked list is 1 to 3 to 4, and the output should be 1 to 1 to 2 to 3 to 4 to 4. And they give you other examples which are kind of the same idea. And if we look at the constraints, the number of nodes in both lists is in the range of 0 to 50. The values of the nodes can be from negative 100 to 100. In both lists, list 1 and list 2 are sorted in non-decreasing order. So let's take a look at this problem. So with linked list problems, it's actually pretty important that you get fairly comfortable with them, because whenever we look at graph questions and stuff that kind of builds upon this, having problems with understanding how pointers and that kind of thing work can often have compounding effects. If you do really well here, it'll help you in the future, but if you've got some gaps of knowledge, this will or can certainly hinder you in the future. So you really want to make sure you have a strong understanding here. So with this merge two sorted list problem, we're given two inputs, right? In the example, so 1 to 2 and 2 to 4, and then list 2 is 1 to 3 and 3 to 4, and the expected output is 1 to 1 to 2 to 3 to 4 to 4. So the way that I'm going to think about doing this problem is using a dummy node. You might have heard of this, maybe you haven't, and a current pointer. And by default, the dummy and the current pointer are going to be the same thing. So what I'm going to do is we're going to loop through both lists while we have both lists that are valid. So if we look at this 1 to 2 to 4, we're going to say, okay, while both L1, I'm going to call this list 1 here, and this will be list 2. So we're going to loop through L1 and L2 while they're valid. Okay, so the dummy pointer is actually going to start off at -1, and this is just going to be a node, and the current pointer is also going to start off by pointing to -1, or the current dummy pointer. So what we're going to do is we're going to loop through L1 and L2, and what we're going to do is do a comparison between L1 and L2. So if the value from, let's say, L1 and L2, so right now they're both pointing to the beginning, if the value of L1 is less than L1, we're going to take the value from L1. So our dummy is going to point to, let's say, L1 here. And I'm going to say value 1 to be specific that it's this node. And then we're going to advance the L1 pointer to the next value or node in L1, and then we're going to continue in our loop. We're going to say, all right, if the value in L1 is less than the value in L2, use L1, which of course it is not. So then we're going to point to L2, and we're going to say this is the L2 from here, and then this pointer is going to move up to the 3. We're going to repeat this process, and eventually you're going to end up with a non-exhaustive list, because you're actually going to be missing some values, because at some point, the way we've written this algorithm, one of these is going to be exhausted. It's guaranteed that one is going to be exhausted. So eventually we're going to have 1 to 1 to 2 to 3 to 4, but we're actually not going to have this 4 here. So what we need to do instead at the end is stitch our, by the way, this should actually be current, not dummy. Eventually our trailing value, if you will, we're going to append it with one final comparison. So just to recap, we're going to start off with a pointer for L1, pointer for L2. These are going to effectively point to the list that we're given, just so we can modify them. We're going to have a dummy pointer and a current pointer. The current pointer is going to be the thing that we basically point to different parts in the list. And the dummy pointer is going to stay the same. And we need this dummy pointer so that we can return the list at the end, because we're going to return dummy dot next. This is dummy. So basically, we keep track of the beginning of the list, and as we move the current pointer through L1 and L2, eventually we'll return dummy.next, and these -1 values are basically there to indicate that, of course, we shouldn't be using these values. All right, so this will make a lot more sense once we look at the code. Okay, so we did mention we're going to have a dummy and a current pointer. So the dummy is going to be a list node with a value of -1, and the current is just going to be pointing to the dummy. And then we need pointers to L1 and L2 such that we can actually modify these, because we can't touch these things that are provided to us in Swift. Now we're going to write our loop. So we're going to say while L1 does not equal to nil. You can write it with the comma, or you can write it with the ampersands. I'm going to use the comma. While L1 does not equal to nil and L2 does not equal to nil, keep looping through this. And eventually, at the end of this, we're going to return dummy.next, and then there will be code here to stitch remaining list. Okay. So while we look at this, we're probably going to be dealing with a lot of optionality. So I forget the exact rules, but we can solve that at the end. So the first thing we want to do is think about the comparison. So if L1.val is less than L2.val, do this. Otherwise, do this, right? So case 1, take the value from first list. Case 2, take the value from the L2, which is the second list. So if we are going to grab something from the first list, we're going to say current.next is equal to L1. We're going to walk both the pointer for the current as well as L1. So we're going to say L1 is equal to L1.next, and we're going to say current is equal to, it doesn't really matter here, we're going to say current.next. And we're going to copy this code over. We're going to paste this in the second block because it's going to be the same thing. It's just going to go the other direction. So instead of L1, we're going to have L2. And you'll notice here, current.next is actually the same in both cases. So we're going to simplify the code just a touch and put this code at the end. So in a specific case, we're going to take our current pointer and point it to the next element in the list. And then we're going to also walk up the pointer for that list. Otherwise, the code would just never advance. And additionally, we're going to do the same thing for the other case. And in both cases, we need to make sure that we walk up the pointer for the current. Now, we have this stitch remaining list code down here. So what we're going to do here is go current.next is equal to L1 equal nil. So if L1 is equal to nil, we're going to say, go ahead and return, or make this point to L2. Otherwise, make this point to L1. And I'm going to submit this code. This is probably going to give me some errors with the optionals as per usual. Right. Okay, so I eventually was able to solve it. It's because current.next, the next is actually optional, so you do need to force unwrap it, but we are guaranteed that there is going to be something there. And as far as the time and space complexity, which I kind of glossed over, the time complexity is going to be O to n plus m, and n is going to be the length of, let's say, the first list, and m is going to be the length of the second list. And the space complexity is going to be O of 1, because we're not really creating collections or anything like that scale with the list of the inputs that were given. Thank you for watching this video.